Assalamu alaikum. My name is Sabah Maqsood and I'm a student of University Islamabad. So today I'm going to show you my lab 8 task of microcontroller and embedded system lab. So basically my week 8 or lab 8 task was to interface analog sensor LM35 using analog to digital converter. So basically this lab was based on ADC, which means analog to digital converter. So first of all, I will let you know what is an ADC. So analog to digital converter is a system that converts an analog signal such as sound picked by the microphone or light entering a digital camera into a digital signal. An ADC may also provide an isolated measurement such as an electronic device that converts an input analog voltage or current to a digital number representing the magnitude of the voltage or current. So basically it is a kind of a device which converts analog signal to digital signals, and this is basically the working of it. An ADC also provides uh, converting voltage or current into any digital number. So basically it can be used for voltage signals, for current signals, for temperature sensing, and there are many uses of it. There are several ADC architectures. So basically due to complexity and need for precisely matched components, all but most specialized ADC are implemented as integrated circuit as it is implemented in here. So basically this was all for working of ADC. So here ADC, the working of ADC is also explained here, that input voltage to a 10-bit digital value through successive approximation. So basically the ADC is enabled by the ADC enable pin ADEN ADC SRS. So we have used these all pins into our code as well. So these are the registers involved in ADC: EEPROM, 1 kilobyte, 512 byte SRAM, static RAM basically, which has 32 general purpose IO lines, 32 general purpose registers, and USART 10-bit ADC. So these are all pins configuration and pins and registers for use for ADC. So but we have to do our code, and we have to do our task in LM35. So first of all, I will let you know what is a LM35. So these are all data sheet and description of LM35. It is used for temperature sensing basically. LM35 is an integrated circuit sensor that can be used to measure temperature with an electronic output proportional to temperature in degrees centigrade. So this is basically the pin configuration of LM35. This pin 3, this leg stands for ground. We have to connect ground to this. We have to connect output to this second one, and we have to connect any voltage depending what we want to give. Mostly we have given plus 5 volt in our hardware. So this is used for that. So this was used for as an temperature sensing device. So its interfacing type is analog output. It has sensor gain of 10, and this is the operating temperature for it. If the temperature exceeds 10, then it will be burnt out. So this was all, and this is all data sheet for LM35. We can, if we want to use that in our task or in our project, so we really have to study on it. We have to search about it, and we should know that what type of sensor we are using in our task and what's its uh, sensing range. So it depends on that. So now coming to our lab task, which was, there were two tasks: implementing the following program that gets data from channel 0 of ADC and display the result on port B and D, and write the program that reads the sensor and display it on port B. So half of the code was already given to us, and we had to code extra in our lab. So basically we had to detect we had to show the sensing. We had to show the temperature on our LCD or on our 7 segment display. It was our own choice using LM35. So basically this is LM35 in our Proteus, and we had to display it on 7 segment BCD or LCD. So we have connected LCD pin to this device, sensing device, and then we have connected other pins to Arduino, as we have done it on it in our other code. So first of all, I will run my simulation. As you can see, whenever I run it, some this temperature will be shown, which will be here 29. There is 29 degree, it is showing 29 degree centigrade on LM35, so 29 degree centigrade will be displayed here. So whenever I increase my temperature, now as you can see 30 Celsius is has been shown when I click on 35. So basically this is how it works. It shows temperature which is displayed in here. So now coming to our code. So as I told you before, half of the code was given to us. We have used LCD library in it to for our simulation of LCD. If we have used a 7 segment BCD, then we wouldn't have used this library in here. In this library, functions are already defined in here, which we have called like LCD display, delay, time. So delay means that after how much time this should be uh, displayed. So I've initialized v and our character value up to 10, and I have given DDRD as an I've displayed it as my input port. I have defined it as my input port. Add mux channel selects ADC5, which was used for analog to digital converter pin. AVCC with an external capacitor at AREF pin. So basically this was used for that. This command enables ADC conversion interrupt is activated through this command. So now coming to the while loop, simply we have displayed our temperature temperature which was shown on LM35. We have written command for that in here. So we are converting the LM35 temperature uh, into decimal for showing it on LCD. So this code was used for that. So here we are dividing ADC value by 9.3. In here we are clearing the flag, ADIF flag, analog to digital basically flag, and we are doing complete conversion for that. So this was code, and then in the end we are clearing our LCD, as you have seen already in our simulation. So basically this was all for our lab 8. Thank you so much.